Good morning, everyone. On behalf of the Global Sustainable Electricity Partnership, GSEP, we would like to welcome you to the Lac-Mégantic Microgrid Project webinar. The GSEP is an organization of leading global electricity companies that promotes electrification and sustainable energy development. Through this webinar, the GSEP showcases valuable educational resources to learn more about new technologies and international best practices in sustainable energy and electrification. Today, one of our members, Hydro-Quebec, will showcase their Lac-Mégantic microgrid project. At the end of the presentation, you will have the opportunity to ask the presenters any queries that you may have regarding the project by typing them in the chat section. Hydro-Quebec is currently commissioning the first islanded microgrid in the province of Quebec. The microgrid is powered by both in front and behind the meter solar generation and energy storage systems. The presentation will consist of a project overview, including the technical and social aspects, with an accent on the key lessons learned during the different stages of the project. This morning, we count with the presence of Mr. David Olivier Goulet and Mr. Patrick Martineau. David Olivier Goulet is part of the Hydro-Quebec team since 2017. Most of his efforts are devoted to the Lac-Mégantic microgrid project, for which he works as a project engineer. In addition, David Olivier helps identifying new initiatives and conducts opportunity studies for the integration of new technologies. Patrick Martineau is part of the integration of new technologies. One of his main responsibilities as a project engineer has been the design and commissioning of the microgrid in Lac-Mégantic. He's also responsible for the microgrid project in the Magdalene Islands and is currently involved in various technological innovation projects at Hydro-Quebec. I will now pass the floor to our distinguished presenters to present the Lac-Mégantic microgrid webinar.
Thank you, Luis, and thank you very much to GSEP to give us the opportunity today to present that beautiful project in Lac-Mégantic. First, I would like to thank all the contributors in that project. As a business unit, our role is a role of integrator to push the innovation on the distribution grid. But without our contributor, this project would have not been possible, especially with the global pandemic that we face. It has been a challenging year, but next week we'll be able to officially commission the site. So thanks to the EPC, the consortium TCS, form of Transelec, CIMA Plus, and also State, that have been working really hard with our team at Hydro-Québec, our expert specialist, WSP also, that has been a technical advisor in that project from the beginning. For sure, our subsidiaries company that provide the utility scale system, and also home automation, and the community of Lac-Mégantic. So thank you very much for your support this year. It will be a challenging year, but I'm glad to present the project for you today. I will start with a quick introduction of the energy transition and the situation of Hydro-Québec and the asset that we have to do that energy transition. And David Olivier will give you a better idea of the project itself, and we'll conclude with the challenges, innovation, and also the lesson learned before the period of question. So David Olivier, thank you for changing the slide. Thank you. So Hydro-Québec and the energy transition, we are well positioned at Hydro-Québec to support that transition in the Northeast. Our sole owner is the government of Quebec. We generate, transmit, and distribute electricity in Quebec for 8.5 million people, and the industry, and also our 4.4 million customers. So as you can see on this picture, we have 27 reservoirs that can store up to 180 terawatt hour of energy. It's enough to power the whole province of Quebec for 1 year. So we like to see us as the biggest battery in North America, if it's not in the world, and for sure the battery of the Northeast of North America. The other aspect of our business is really the fact that we are 99% renewables in terms of energy. We rely on a really strong production side for hydropower, but also wind power. And the GHG emission of our installation and our electricity is 70 times lower than the one from coal generation. So we're well positioned also in terms of cost. So we have the lowest rate in residential rate in North America, and also on commercial and industrial rates. Though it's an asset, but also it makes sometimes challenging to make the economic on some of the technologies that are deployed elsewhere in the world, where the cost of energy is much higher. The other transformation that we face and opportunities also is really moving from that one-way model of power flow from centralized generation, transmission, and distribution to our customer, really moving forward to that new two-way model of producing, distributing, but also bringing more energy from our customer or generate more opportunities with our customer to better manage the transit of energy on our grid. This brings us some challenge, and we'll show you later how we can rely on projects like Lac-Mégantic to solve these challenges. The key driver of that transition for sure is the decarbonization. And I already mentioned that we're 99% renewable in terms of electricity, but we still face challenge in Quebec to reduce the emission of transportation. Also with the electrification of everything, industrial processes, also heating of commercial and institutional building. So we have to do it smartly in order to really build on that asset that we already have. And we have also this trend and this opportunity of democratization of the decentralized energy, and also that digital transformation where we can bring energy closer to our customer and make sure they can contribute to that transition. For this introduction, I will conclude with the disruptive technologies that will be deployed at Lac-Mégantic and that have been deployed elsewhere in the world. But what will make Lac-Mégantic really special is really the fact that all these technologies will be deployed from electric vehicle, solar panel, energy storage at the distribution level and behind the meter, and also smart building. As I already mentioned, we'll be deploying solution developed by our subsidiaries company in residential buildings, but also we are testing also new topology to integrate more renewables behind the meter into commercial and industrial buildings. So we have a wide variety of technologies and topology within a small footprint. So I will let David Olivier give you a better idea of the specific intervention that we'll do in Lac-Mégantic. Thank you.
Thank you, Patrick, and thank you, Louis, for the introduction. So yes, as Patrick mentioned, I will now present you the project of Lac-Mégantic's microgrid. So this project is the Hydro-Quebec's first islanded microgrid in the province of Quebec. And for those of you who don't know Lac-Mégantic, it is a town located about 3 hours away from Montreal. So if I can start with a quick project background. So the story behind this project, first of all, started back in 2013 when there was a big tragedy in Lac-Mégantic, which left the city center, the downtown area, to be reconstructed. So the town of Lac-Mégantic, they wanted to take this opportunity to turn itself into the future and start focusing more into innovation and sustainability. And at that moment, we at Hydro-Quebec had been looking into the microgrid technologies for quite some time, and we're looking for a location to implement our first microgrid. So the partnership between Lac-Mégantic and Hydro-Quebec was really started from a mutual agreement where a community microgrid project made sense for both parties. So this is really how we started this partnership back in 2017. So the objectives for Lac-Mégantic, they had a lot of objectives with this project, but really the main objective for them was to position their city as a transition leader, not only in Quebec, but for all of the rural Canada communities. They also wanted to make the vision, Lac-Mégantic's vision of a smart city, a smart hub, a reality by integrating those new technologies and innovation into their town. Of course, the project will help increase the town's appeal as both an economic and technological hub of innovation right into the heart of Lac-Mégantic. For us at Hydro-Québec, we had a lot of objectives also with this first microgrid project. First of all, this project helps us master all means of generating and managing energy at load centers. As Patrick mentioned at the beginning, we at Hydro-Québec, we have a grid that is mainly composed of hydro generating stations. So the decentralized generation is something that is really new for us, that we had never been experimenting. So we really want to see how those decentralized generation solutions affect not only our grid, but also our customers. So we really want to learn from this project here in Lac-Mégantic. Another thing we want to do is to master the two-way exchanges and the concept of islanding of the microgrid. The model that was developed for Lac-Mégantic is a microgrid that can be islanded. So the microgrid can produce and export its energy onto the grid. It can also import energy from the grid when needed, or can work completely standalone as an island. If, for example, there is a power outage on the main grid, or if we know we have the resources and want to island the microgrid for a specific amount of time. One of our objectives is also to manage our demand during winter peaks. We in Quebec are winter peakers, so on those cold days during winter, there is a really high demand, and it causes a lot of pressure on our distribution grid. So we really want to use the technologies deployed in Lac-Mégantic to try to reduce this demand during those peaks. So using the energy storage, the energy stored into our batteries during those specific periods during the winter. We also, of course, want to understand all those, what are the user adoption factors. So in the project with Lac-Mégantic, we built a community of practice to really try to capture all of the users' feedback from those technologies from the microgrid project in order to better understand those user adoption factors. And last but not least, one of our main goals is really to apply the model developed at Lac-Mégantic to our off-grid systems, our remote networks, to reduce our fossil fuel use and reduce our greenhouse gas emissions. We have a lot of remote networks in the northern Quebec that are powered from non-renewable resources. So we really want to see how we can learn from what we deploy at Lac-Mégantic and deploy those technologies onto those remote networks. Here, I also want to mention what makes this microgrid project so special for us. What we try to do here and what we did at Lac-Mégantic is really push the microgrid solution a step forward as we really push the limits to not only do interventions in front of the meter, but also went behind of the meter of our customers. So we really wanted to integrate integrated DERs behind the meters at our customers, work with our customers, work with the community. So it really makes this project special. Not only that, also our microgrid will be 100% renewable microgrid. So during operation, there will only be solar generation and energy storage systems and no generators, as we can see in other microgrid projects. We used a genset during our testing phase this fall, and we used this genset to achieve our goal of learning from this project to apply it to our remote networks where we have gensets in our northern communities. So we really wanted to have a genset during our testing phase to learn from how it could be coupled with this solar and energy storage systems. But this genset has been removed from the project for the operation of the project. So if we go more into detail into the project itself, the project is divided into three intervention types. So first of all, we have our energy generation. As I just mentioned, we do not have a genset here. So it is only solar panels, about 2,200 solar panels. We have both in front and behind the meter solar panels. Then we have our energy storage. Since we do not have a genset, when we are landed, we need the energy storage system to have those grid forming abilities. The energy storage system has to be able to do the tension and frequency regulation. So we have a big centralized solution that is provided by a subsidiary company that is 600 kilowatt hours of energy storage. And the other 100 kilowatt hours is again behind the meter into our customer's building. And then there is the energy management part. First, we have our centralized control system, which is most commonly known as a microgrid controller. This is the heart and the brain of the microgrid, and it is located into the microgrid substation right next to the energy storage system. Then, as Patrick mentioned, we have smart buildings. So we equip buildings with smart devices, and not only commercial buildings, but also went into residential units to implement those smart devices. We also did energy efficiency measures and installed an electric vehicle charging station in the middle of our microgrid. Here is a picture.
I will please ask a couple of minutes since we're having some connection difficulties.
Maybe Luis, I can jump in, and since David Olivier lost connection, I think I can share. I can continue to present, and he will join us back. So, Luis, just double check here. Do you see the screen fully, the full screen? Oh, David Olivier, you're back.
We can you?
So, Luis, are you? Do you see the screen, the full screen?
Yeah, can you hear me now?
Yes, you're good, David.
Yeah, I can see your screen, Patrick.
Sorry, Patrick, you can share the presentation. Sorry, I don't know what happened with my connection here, but maybe I will stop the my video and you can share the presentation.
Perfect. Actually, I will let you continue, David Olivier, on where you were on the microgrid and the area of the microgrid.
Yeah,
and
you can
switch the slide.
Yeah, you can switch to the next slide. Okay, so here is a snapshot of the microgrid perimeter area. So on the top right, you have the sports center. This is the building we just saw on the picture on the previous slide. And right next to this sports center, we have the microgrid substation. So this is where we have the centralized energy storage system and the control center. All those other buildings you see with all these logos is where we installed those DERs and where we did those energy efficiency measures. So you can see that we really tried to address as much building as we could. And you have the microgrid connection point at the bottom in the middle. This is actually a circuit breaker that we can open in order to island the microgrid to be disconnected from the main grid, or we can close if we want to go back to the main grid. And both those transitions are done seamlessly for the customers. Next slide, please. Here is some pictures of the buildings within the perimeter. These are the buildings, the railway station, where we integrated energy storage behind the meter. The MRC building has both solar generation and energy storage. Concerto has those solar panels on the roof. Same thing with Service Canada. And Promenade Papineau is where we did energy efficiency projects. Next slide. Status of the project, as you can see in those pictures, the construction is complete. You have the sports center on the top right and two other buildings, which is the Concerto and the MRC Service Canada with the solar panels on their roof. And on the bottom left is the microgrid substation. The picture was taken from a drone while it was still under construction, but you can still see the blue container is the control center. And the two containers left to that blue container are the energy storage systems provided by our subsidiary company. They are both 300 kilowatt hours per container. Next slide. So timeline and work schedule of 2020. 2020 was a huge year for the project. The construction of the project started in spring 2020. We were about to open the construction site just when the pandemic struck. So we had a couple of weeks of delay before opening the construction site. But really, the teams worked really hard all summer and fall in order to catch up on those delays. And they were successful. We were successful as we were able to achieve our goal, our objective of commissioning the project before the end of 2020. And as Patrick mentioned, we are commissioning next week. So the fall was really the testing and commissioning. As I mentioned, we brought a diesel generator to do some tests. And now we are just finishing those tests and commissioning in the middle of next week and starting operation at that moment. Then work planned for 2021. It's not over. There is still some work to be done. Here you see the microgrid pavilion, which is a solar generation shelter. Of course, there will have some solar panels on the roof. This solar shelter, this pavilion, will be located right into the heart of the microgrid. This will really be the emblem of the microgrid. Where citizens and visitors will be able to meet, to relax, and also to learn more about the project as we will have a dashboard. This dashboard will be a digital dashboard with live information about the microgrid. So people will be able to see the status of the microgrid. Are we islanded or not? What is the status of the energy storage, the batteries? Is there energy in the batteries or not? What are the solar panels producing at the moment? So really going to be an interactive pavilion, and is really going to be the goal of 2021 in the first half is to construct this pavilion. Now, Patrick, I will let you continue.
So thank you, David Olivier, for that portion of the presentation. I will speak about the challenges and innovation or recap because some of them have been highlighted already by David Olivier. So first is the wide variety of technology that we have to integrate at Lac-Mégantic. Actually, not that we have, but that we have decided to do. So it was an ambitious goal. So all this integration, there are a technical part of it. There is also the human part to it. So how this will be optimized. It won't be optimum for the day one. So that's why we'll operate the microgrid for the next few years to make sure we optimize all these controls and within the building and also at the distribution level. The microgrid being 100% renewable without any inertia. So as mentioned earlier by David Olivier, will rely on our subsidiary company centralized energy solution. So that solution has that seamless transition ability and also be able to do blackstart. So everything that is behind the meter do not contribute to these functions. It's really relying on our technology, not only the chemistry of the battery that is developed by Hydro-Québec, but also the control, the EMS, energy management system of the battery itself, which is integrated with the microgrid controller provided by a smarter grid solution. So all this integration and all that work that have been made by our expert and the expert from TCS has been challenging. And the other aspect that we still have to optimize is the forecasting models, not only for the generation, but also for the load forecasting. So initially, the microgrid will be operating with a level of performance. And what we expect through the operation is really to optimize this model, the limits, and increase the performance of the installation. For us, it was important to be operational this year so that we can contribute to demand or peak during winter time. So for us, it was a lost opportunity not being able to do that contribution. So we'll learn from that first winter for sure. The other aspect that has been mentioned is the short-term duration test operation with a diesel generator. So initially, the project was really focused on remote communities, how we can translate these technologies in remote communities for that aspect. But we see a lot of benefits also of the project on the main grid. So all these expertise can be also transposed to the main grid on these innovation. And specifically from the one or the interface with our distribution operation center. So the way we've developed that telecommunication strategy within our system, and also the specific automation system that we've deployed. We have more than 4,000 automated devices on our distribution grid. So we had to develop a new topology and also different production schemes associated to the fact that we'll be operating the grid. We have with really low short circuit current abilities from the battery. So we had to think or rethink the way we operate the grid to integrate more renewables. The other aspect that will be really important moving forward is standardization. So if we want to industrialize and put more microgrid and accelerate the transition in many aspects of the project, is standardization. The project and the specification has been based on IEEE 2030.7. It's a standard that we've been involved in the development at Hydro-Québec, and we believe in that standard, but there's a limit to these standards. So you have to try these standards, see their possibility, also their limits, and bridge the gap with our own standard. So we operate the grid with specific requirements. So the project was also the possibility and the opportunities to change these ways or these standards. The other aspect or the other place where we see a lot of value is really at the interface between buildings and utility distribution grid. These are different set of expertise. But we have to talk to each other. So standards can bring like expertise together, can facilitate this point of interface. But through that two-way exchange model, we have to move forward and develop a new way to collaborate with experts. And through the Living Lab, we think moving forward and community of practice that we put in place at Lac-Mégantic right now, that it will give us the platform to better do that interface and move forward. It has been challenging this year to put these community of practice in place. There's a logistic, there's bringing people together. So we did it virtually. We hope moving forward that we'll be able to rebuild that one-on-one synergy that is so important in that type of project. And finally, before the period of question, I would like to conclude with lesson learned. Actually, we will be commissioning the microgrid next week. We'll have to take a step back as we did through commissioning phase. After the commissioning phase, we took a step back. We made a workshop, a postmortem with the team. For us, it's important to learn from these projects and then do better next time or differently. So we'll do this beginning of next year. We'll have some holidays. We'll take some time, some rest with the family, and I think we'll have our idea clear. But one thing is sure, it's the social acceptability. It will be part of that. It's a positive lesson learned. Get the community involved from the start. It's really important. We started that project in 2017 with high level, with a dream, I would say, with high level objective and vision. And we built the trust with the community, and we found the complementary objective. And moving forward, sometimes we get into technical details, a lot of complexity, but we had to get back to these global or the initial objective and vision to guide the project team. So it's really important to do that. And David Olivier, I will let you jump in on maybe the funniest part of the social acceptability. We can see you on the screen here.
Yes, yes, Patrick. This picture was taken at an event that was last winter or the winter before. I think it was last winter, if I remember correctly. But this is to show that we really partnered with the city, and we went to those events to present the project to the citizens. We really wanted to make sure that they were a part of the project and that we would get their feedback and their social acceptation for sure. This was something really important for us. So yes, we put on our hockey jerseys quite a few times and went to those events.
And the more formal communication also is important. We've been in local media to explain the project, every step of the deployment, to explain where we were at and where we were going. It's important for us. And also on social media with the team, our communication team did a great job. And also the team at Lac-Mégantic. So they formed a team at one point to get that unified communication plan, which has served the community and Hydro-Québec very well. So we appreciate the work and effort. It has been a key aspect of social acceptability. Innovation also, we are a big organization. We want to be more agile. We have the ability to do big projects. When we get in smaller projects, we also have to keep that startup spirit, but keep the expertise that we have behind. So we really have to find the way, and I think at Lac-Mégantic, with the team that we've put in place, naturally innovative project bring people together. So I think it's a great achievement. And Lac-Mégantic did the same on their side when they had to rebuild the downtown area. They formed a special team, and we've been working with that team at Lac-Mégantic with the same spirit, which has been really a key aspect of the success of the project so far. Listen, the end user, the community, and seek guidance. We started this project being humble. It's our first microgrid. We have a lot of expertise, but we still have a lot to learn. So we've been doing a good overview, and we've been visiting other microgrids. We seek guidance with technical advisor. I've mentioned WSP already. So their inputs from their also international expert have been also really a key aspect of the success of the project. And finally, and I will conclude on that before the question period, is testing and commissioning. Our team, project management team at Hydro-Québec Distribution, TransEnergy and Equipment have developed from the get-go really early cooperation between all experts, not only from Hydro-Québec, but also from our EPC. And this work has been really useful and come at play when you get these technical challenges on site, how to execute and be agile. It's true like plans. And as Anawar said, like plans are nothing, planning is everything. So we've been replanning all the way during the commissioning phase. And before the period of question, I really want to reiterate our thanking the community of Lac-Mégantic. I just want to show you this logo that has been developed by our communication team. You can see the Lac-Mégantic Hydro-Québec surrounded by small dots. Lac-Mégantic in 2007 has been the first international dark sky reserve that has been approved by International Dark Sky Association. So at the time they had vision, they had leadership, and they've put in place something that is really innovative to preserve the observatory reserve. Today, they want to position themselves as a leader in the energy transition, and with the community they have, with the vision and the energy they have, I'm pretty sure we're getting there. And where Mégantic may be C-star, we might see Electron on Quebec, Hydro-Quebec side. So, and finally, the federal government through their grant for the Green Infrastructure Program to get the more smarter grids in Canada, and also for us, it's the ability also to share the expertise that we develop in Lac-Mégantic, not only elsewhere in Quebec, but also with other utilities in Canada. So this concludes the presentation, and feel free after the period of question, if you still have questions, to reach out with us, and also visit our website that is up to date, and we'll keep keeping posted the project overview. Thank you.
Thank you, Patrick. Thank you, David Olivier, for your presentation. I would now invite participants to type their questions for Patrick and for David Olivier on the chat question. So we have here the first question that says the following. It looks like the community of Lac-Mégantic was a stakeholder in all phases of the project. Can you please talk more about that, and how did Hydro-Québec manage to ensure that the project would meet the community's expectations?
Yes, I will go, Louis. So, of course, the community of Lac-Mégantic was more than a stakeholder for all phases of the project. It was actually a partner with us through all the process of the project. One of the main challenges of such a project is to make sure that we, as Hydro-Québec, make sure that the project we develop not only meets our requirements and our objective, but is also in phase with the objective of the community and of the city. Otherwise, the project doesn't make sense and won't be successful. So we made sure that from the get-go, they were working with us. They worked with us from the project definition. They worked with us during engineering phase. They worked with us a lot during the construction phase, and we will still continue to work with the community end to end for the next years during operation, and with the community of practice, the Living Lab. So the partnership, I think, was maybe one of the things that I'm the most proud about this project, is that really this was a project that was done together, City of Lac-Mégantic and Hydro-Québec. It's a huge success.
And if I may add to that, maybe one key aspect is not only to keep that project with the technical team, but make sure you bring people that have other abilities in communication also. So our colleagues, both at Hydro-Québec and Lac-Mégantic, for that aspect, for social acceptability, has been key players in these type of project when you're close into a community. So again, thank you for that contribution from our team. It has been really a key aspect of the project.
Camilo congratulates you on the incredible project, and he asks, could you please provide some few details about how you have done for the forecasting for the generation and the demand?
For the forecasting, actually, we've been sizing initially when we scoped the project. we've been relying on information that we had from the meter, but we had also to project what will be the future development of the microgrid. So we had to do simulation, energy simulation, and evaluate what will be also the growth of the downtown area. If you remember well, there was a lot to be rebuilt. So when we started first, the simulation were more aimed to predict what will be the growth of the downtown area and where we can also define the perimeter of the microgrid. So once that has been set, then we've started to, there's too many possibilities that we can go after. So once this perimeter was set, then we've been working with the EPC in charge of the project to better define the model, the optimization model that will be used. So as we speak right now, we're still working on these optimization models. So we might give you more details, and my colleague can give you maybe more details offline, so if you will.
The next question from Nicolas. He asks, why have you chosen to use solar panels instead of other generation of other energy generation technologies?
Yeah, I can answer here. As we mentioned, one of the main goals was to not have diesel generators, so this production mode was out of the question. And then we were left with what are the renewables we can integrate into a microgrid. In the case of Lac-Mégantic, since we are in a community in the downtown area where there is a lot of buildings, the solar generation was the generation mode that made the most sense, since we had space on the roofs, and that the roofs were strong enough to accept this new load. And then for sure we can think about wind generation, but in our case this would have made no sense because of where we are implementing the project. As a wind turbine would be way too big and would of course not fit into the city center of Lac-Mégantic. So really for us the solar generation was the one that made the most sense. But of course, if in the future we deployed different microgrids or different type of project, we will look into those other new technologies in the future.
The next question from Yvon. Has the project taken into account cybersecurity, the cybersecurity dimension, to eventually reinforce the capacity of the network to better manage potential cyber attacks?
Yes, this is, I think, a concern of all the industry, like when you bring more decentralized and you do the IT and OT interface. So yes, this has been a key aspect of the specification at first, and also a key aspect of the validation through the development phase, engineering phase, and still is right now through the commissioning. So all the steps for commissioning to validate that the requirements that we have are met. We're right now like finalizing these validation.
From Ikena, he would like to know, how do you moderate the increasing load from the customers?
Yeah, as Patrick mentioned, when we started the project, we looked at the load of the downtown area with the meters. We could have this the actual load of the previous years. And we also looked into the future. Right at the beginning, we looked at what was upcoming for the downtown area. So we knew there were new buildings that were going to be built in the next few years. Some of them have been built in the last year or so. So we looked at all the possible buildings that could be built, and we took like an average load for such a building for what we are used to see in other buildings around the province. And we took these loads and added it into the project scope, project definition. So we really defined our project as if we were fully constructed with all the loads. So we know that what we have installed will be compatible when all the new buildings will be constructed.
And if I may, as a complementary answer also, we've been working also with a local firm that do building projects, so they understand the project. So we've developed interface and documentation so that a new promoter that want to integrate the microgrid better understand what they can do to support the microgrid, the objective of the microgrid, and also the expert that work in the region to build the buildings also have this information. So when we talk about communication, also technical communication is key aspect.
Eduardo congratulates Hydro-Quebec on the project, and he asks if you have evaluated the possibility to use hydro or hybrid diesel hydrogen generators, especially because in Europe they have a new generation such generators, and their main obstacle is pricing of this type of electricity to produce hydrogen.
Yes. This for the project of Lac-Mégantic, this is not a technology that we studied or that we wanted to implement here. And of course, even though it uses clean hydrogen, if it's a hybrid diesel and hydrogen, this implies diesel, and we really didn't want to have any diesel in this project. But of course, clean hydrogen is something that Hydro-Quebec is looking for in the future, but for the specific project of Lac-Mégantic, this was not something that was studied.
From Yvon, he would like to know, how is this project related to the energy transition plan of Hydro-Quebec? And if it is contemplating in Île de la Madeleine, the largest off-grid network in Quebec.
Yes, there is many aspects of that project that can be transposed elsewhere. One of this aspect is really how we integrate more renewable into the buildings behind the meter. So when we have a microgrid, also we have a remote communities, which is the biggest one in Magdalene's Island, and there are opportunities through that the energy transition that some of the technologies that we've developed or topology that we've developed in Lac-Mégantic will be able to transpose in Magdalene's Island. But we also have a project, a microgrid project in Magdalene's Island, when we see we'll be developing specific technologies that can be transposed and more adapted to the reality of the Magdalene's Island.
From Adriana, she would like to know, what is the primary barrier to leveraging DER technologies at a scale across the utility network?
I can take one portion of it, and David Olivier will let you conclude, because there are many challenges. One of these challenges is really the interface with the SCADA from the utility. So I think with a project like Lac-Mégantic, right now we have a better vision of how we can do it efficiently. The other aspect is the way you operate the grid. Now, so we have to adapt the way we work. So we had to do specific standard for a microgrid, internal standard at Hydro-Québec on how we operate the grid in various situations. So it has been a lot of work also that have been made by our team that developed these standards. So it's one of the aspects also that when you scale up the DER, you have to adapt the way you work on the grid.
Yes, of course. And just to conclude, as I mentioned earlier in the presentation, this is one of the key objectives of the project, since these DER technologies is something that is really new here in Quebec, that because of the electricity prices and the fact that we are 99% renewable, the adoption of those DER technologies is a lot slower than what we can see around the world. Then we can use what we learn here in Mégantic, and as Patrick mentioned, see how those DERs affect our grid and how we can manage to manage those DERs actually on our grid.
From Agustin, At the level of consumers, I realize that there will be more prosumers in the new model. What modifications have you presumed to cause the homes to furnish the grid with energy?
Actually, did you get maybe the last part of the question, Luis? I want to make sure I answer well the question.
What modifications have you presumed to cause in the homes of the consumers based on this new type of energy provision that you guys will do through this project?
Maybe I will try and answer, like, to make sure I cover the question. One of the things that we have to look at when we're talking residential or commercial buildings, the opportunities are different. And when we're looking at new buildings as opposed to existing building. So it has been the challenge that we've been working with an opportunities in Lac-Mégantic with all the diversity of buildings. So with new buildings, like there is a new fire station that will be built next year, we have much more flexibility to intervene upfront into the specification of the building. So we have opportunities to change the way the electricity distribution is made within the building, make some choice on where we connect, which load we connect on the other. When we talk existing building, we have more limitation. So this is more challenging, but moving forward, if we can learn from this project and transpose these requirements into codes and standard that makes sense for the customer and for the reality in Quebec, it's really our vision moving forward to make sure that we integrate this and it becomes transparent for the customer and integrated into the construction.
Claudine asks if Hydro-Quebec is planning to build a second microgrid in Quebec.
Yes, well, Patrick talked about the Magdalene's Island project that is currently underway. But most generally, what we did in Mégantic, we really pushed everything into Mégantic, did the whole package where we had solar generation, energy storage, highland, double microgrid. But what we can see for the future is trying to use some of the technologies that was deployed in Lac-Mégantic into other applications. So we can see maybe 3 axes where we can intervene or have microgrids or some part of microgrids in the future. And one of them could be the remote networks. So networks that are on our grid, but far from the substations, places where the quality of service is poor, places where they have more outages than the rest of the province. We want to learn from Mégantic how we can deploy the technologies that we use in Mégantic into those remote communities in order to provide a better quality of service. This could be one axe. The second one is for the substations that are loaded, that are already saturated, that let's say is a really crowded area where the substation would need investments in order to provide the electricity and the power for all the lines on the substation. So we want to use technologies, microgrid technologies, in order to postpone investments onto those substations. So really, this is another aspect that we are looking for with the technologies deployed in Lac-Mégantic. And the third one, as we already mentioned, is for our remote networks in the northern Quebec, the networks that are not connected to the main grid. Really, this is the main objective with what we are doing with the microgrid in Lac-Mégantic.
Another question from Yvon. He says, there is many off-grid networks in operation or under tests elsewhere. Have you visited some, and how do you see your project being different from others?
There was actually at the initiation of the project a visit that has been organized with our team. I wasn't there at the time. It was, I think, in 2018. And really, like, we've been visiting other microgrids operated in North America. And it really helped the team to better scope the project and see there's nothing like seeing what has been done, visiting and see the opportunities, but also the limits. So we wanted to make sure we get all this information. And during also the procurement process, we decided to move forward with the performance-based standards, so specifications. So in that case, with the RFP, it was possible also to see all the possibilities that the market can offer in terms of topology or technology. So these two aspects has been important to better choose the project and the technologies for that microgrid.
Yes, and maybe one thing that I can say that really differentiates our project from different microgrid is really the fact that it's 100% renewable, so no diesel generator or no generator at all. So really, this is something that makes this project special, and the fact that we went not only in front but behind of the meter also. So yes.
Ikena asks, assuming that you have all the needed resources to replicate this project in any part of West Africa countries, what challenges do you envisage, and how do you think this would be viable? You would like to replicate this project somewhere else?
My answer will be modest because I don't have all the understanding of the challenge they have in West Africa, but in terms of grid. But what we can see moving forward, there's a lot of opportunities in area where there's already infrastructure installed, but there's also elsewhere where there's no more infrastructure or not much infrastructure installed, and we see a big trend also into deployment of DC microgrid in these areas. So I would say it's difficult to answer since I don't have the perspective of West Africa, but the possibilities have to be tailored with the situation and the asset that is in place.
Perfect. Thank you very much. I think those are all the questions we have received right now. On behalf of the Global Sustainable Electricity Partnership, I would like to thank you all the participants. I would like to thank you also Patrick and David Olivier for your presentation. Again, if you have additional questions in the screen, you have the emails from Patrick Martineau and David Olivier Goulet, who are the persons in charge of this project. You could also contact the Global Sustainable Electricity Partnership for any additional questions regarding the project as well, and we'll be glad to forward all those questions to David Olivier and Patrick. Again, thank you very much, and it was a pleasure to have you today, Patrick and David Olivier.
Thank you very much, Louis. Thank you, everyone.